Welcome to this joint webinar of Welotec and OMICRON. Anton Krupskii from Welotec is going to meet Fred Steinhauser from OMICRON. They are talking about centralized and virtualized protection, automation and control systems. Anton Krupskii is a business development manager at Welotec. With a focus on substation automation, he drives innovations in computing hardware and virtualization technologies and actively participates in shaping the future of the power grid. Fred Steinhauser is a digital substation evangelist at OMICRON. After initially working on testing power system protection, his focus shifted to power utility communication. He participates in IEC 61850 standardization and tracks and promotes technologies required for the successful implementation of digital substations. In today's dialogue, Anton and Fred will talk about several topics around vPAC and CPAC, such as trends, what's going on in the evolution of PAC, software and hardware requirements for CPAC and vPAC, the benefits for the industry, how will we test centralized and virtualized systems. Following the conversation, there will be a Q&A section where Anton and Fred will address your questions. We hope you find the discussion informative and entertaining.
Hi, and welcome to our online event on centralized and virtualized protection and control. I'm Anton from Welotec, and I'm here together with Fred from OMICRON. First of all, hi Fred.
Hi Anton.
I'm glad that I got this opportunity to talk to you about this crucial topic. As I come from the computerization world, and you have massive background in electrical engineering, I believe that for the wide audience it would be very interesting to listen to us and understand the perspective of both of our sides on this crucial topic. The reason why I offer to have this conversation is that in the recent times we get a lot of questions on virtualization itself and also on centralized and virtualized protection and control. While virtualization is not a new technology and protection and control solutions have been developed for many decades, why do you believe it's been so widely discussed in the recent times?
I'm not absolutely sure why, but maybe the time has come for this technology. And we as OMICRON, we do not build PAC equipment, but being involved in the testing of this kind of equipment and me being in the digital substation world, I just feel that there is something going on. And surprisingly, it's not so much the vendors who have brought up this topic. There is really a pull from the users. And this kind of openness really surprises me, because when I look back on many experiences that we made over the past 20 years when we tried to promote the idea of IEC 61850, we faced a lot of skepticism there. Now, of course, not the entire PAC community is now a fan of CPAC and vPAC, but there are more opinion leaders and early adopters who really promote this idea, and I think they have a vision and know what they expect from it.
Okay, that's an interesting point. And I think it helps a lot to take a look on it from the utilities perspective, because what I felt is that this shift towards virtualization was driven by from the energy transition and their need to make the infrastructure more flexible and more scalable in these terms, to make sure that the grid is stable enough in this changing world, while we adding much more renewables to the system, while we make the grid bidirectional. This is where digitalization actually comes into play. This is where we cannot ensure the stability going conventional. So in terms of digitalization, what do you believe are the key enablers for that?
Yeah, I said the time has come Also because we have a lot of technical preconditions now in place that we did not have before. And I already mentioned IEC 61850, which brings us these communication services so that we can exchange the data with the centralized systems over communication protocols. To mention especially now the sampled values, where we have the process bus and can deliver the sensor signals from the process to the centralized protection. If we wouldn't have that, it would be hard to imagine how we would conventionally wire up such a system. So I think 61850 is an enabler, and on the other side, the developments that we had on the computer side, and the experiences from the IT world with the virtualized platforms.
Let me clarify this. I believe it is important for our conversation to understand the path, how we came to the centralized protection and control, and how it can develop further. So protection and control solutions have made a huge path. So in the very beginning, correct me if I'm wrong, we had many different boxes, and each of them had their own job they did without talking to other devices. As the demands have increased and as the technologies got better, big vendors started to producing devices which we call IDs, which are widely used nowadays as well, which helped us to monitor and analyze processes in the substation in a much more efficient way. We started using IEC 61850, so the devices started talking to each other, which increased the efficiency once again. And for a certain point, it was a great breakthrough. But is it actually an optimal way to run protection and control, or are there any limitations in the centralized protection and control on dedicated hardware devices? How do you see it?
This CPAC solution on a proprietary hardware base is available already since a couple of years. But in general, these solutions lack flexibility and scalability. As it is a custom hardware, it will not be produced in very high numbers, and so we are lacking the economy of scale. And of course, third-party products running on these application platforms will be not well or not be supported at all. And also the speed of the technological development will not be as fast as in the mainstream when you are limited by your proprietary implementations.
That's true. And I believe this is where virtualization actually comes into play. And what virtualization allows, it allows for emulating the hardware functions through software. And you're getting a lot of benefits thanks to that. So you have flexible and efficient use of resources. So you can run multiple applications on one physical box, on one server. And then, of course, you can run those applications that ran on an ID on a hardware solution that is not dedicated to some vendor. And of course, you have additional benefits like snapshots on the system and many others, which actually allows you for much more flexibility. But what is obvious that this, while it's a game changer for the industry, it would totally change the product business. What do you think? How would it change the business that the vendors are doing there?
Yeah, even those vendors which already have their proprietary hardware-based centralized platforms and solutions, even they are moving toward virtualized systems. So you could say they are cannibalizing their hardware-based business in favor of the virtualized systems because they see by themselves that the scalability of the hardware-based solution is limited. And by virtualizing their CPAC systems, they overcome these limitations and can go further and be more flexible in their offerings.
Yes, that's true. What I also have seen that they try to stay in the early adopters list. They try to be even more flexible and much deeper involved in the very latest developments. And this is where they all were brought together by initiatives like the vPAC Alliance. What we see there that the vendors and other players have come together to work on a joint solution there. And the main idea of the vPAC Alliance, which is promoting the vPAC, is to bring all major players from different fields together to work on the requirements for the whole vPAC system. Because what we have seen previously, that each vendor has worked on their own products and bringing the product to the market, while we, for example, as hardware manufacturer, was struggling on finding the right hardware platform for those applications, and utilities were trying to find the right solution for their needs. This is actually a great idea to bring all of those together. And if we take a look on the vPAC Alliance, there are utilities, hardware manufacturers, vendors, application providers who set together to work on the requirements for the whole vPAC solution. And I think it's crucial that we all contribute to this shift towards the greener power transition, and that we all ensure that the grid stay stable in this changing world.
Yeah, that's actually an interesting point with this vPAC Alliance. When you look at the composition of the membership, there are many, I would say, newcomers to the PAC business, which were simply not present in this field of expertise, but they are bringing in now new competences and new technical possibilities. And you also mentioned the utilities, which are there from the beginning to express what they expect and what they want from this, without a vendor telling them, hey, I could give you this and that.
Exactly, and this is, I see it's the main benefit of this whole thing, because it would be difficult to promote vPAC if only vendors and solution provider would talk much about that, but we see a lot of interest from the utilities for that.
When we are talking about equipment that is fit for the use in a substation, we always had a lot of discussions about the hardware requirements. I think when it comes to CPAC and vPAC systems, it will not be much different, and this will be asked in the vPAC Alliance just as well.
The requirements in the hardware is pretty the same as to other hardware, but when we talk about virtualization, a couple of things are a little bit different. So in general, if we talk on the hardware platform, the computing hardware platform, it should meet the requirements of the standards. These are two main standards, the IEC 61850-3 and also the IEEE 1613, which describe the requirements on the resisting to shock, vibration, AMI, temperature, low temperature, high temperature. This was made to make sure that the hardware that is working in substation would not fail in this tough environments. Then we also have such thing as the architecture of it, and we should make sure that the components that we are using would support, for example, the latest operational system and the applications that are being developed in the field. We need to make sure that we have the interfaces that the engineers will be using in the field, and of course we need to make sure that we have enough computing power there, so that we have enough computing resources, not only for the today's needs, but also that we have left the room for further developments and for the further needs of the utilities.
Yeah, regarding this question of computing resources or performance in general, I heard an interesting presentation 3 weeks ago at the DPSP conference in Manchester, where a person from a utility presented about his vision of vPAC, and he made an interesting remark that he said, we don't have a performance problem with these vPAC systems because what these modern platforms, these servers deliver is much more performance than what the old boxes had together. And so they even see better performance on these vPAC systems than compared to the classical systems.
That's true.
But besides the hardware requirements, there is also new kind of software involved, and I think there will be software requirements just as well.
For sure, for sure. So if we talk about the software part, which is actually the key or the cornerstone of the whole solution, I would also like to separate two parts of it. So on the one hand, we have the applications themselves. So for example, the protection and control applications or any others. So if we see in the functionalities of those, they're pretty much the same as if you would just normally run them on a computer. So you have the same functionalities. No matter if you virtualize protection and control or a firewall. A virtualized firewall would have the same functionalities as the normal one. And there is also this second part. And when we talk about virtualization, there is such thing as a hypervisor, which is a key thing enabling the virtualization itself, because it allows us for starting the virtual machines on the server. And nowadays there are not so many hypervisors on the market, and we need to make sure that they run on our hardware and that they are capable of doing real time if we talk about virtualized protection and control. And nowadays there are even less hypervisors who support it. I believe that for everyone it's not a secret that there is the VMware with their ESXi. There's also the open source product CPAC developed by the LF Energy.
When I listen to the discussions about implementation options, I often hear the two terms virtual machines and containers. Do we already see how this will work out?
Okay, so basically both of them are the approaches within virtualization. So you can either run virtual machines on your hypervisor or deploy containers. So basically, yes, not only in protection and control, but also in other applications, there are two different approaches. And applications should be developed from the very beginning with one or the other way. So containers are considered to be more optimized, to use less resources, which allows you to utilize even more applications on your server. Yes.
Okay, and something else which I always consider important for digital substations are the topics of time synchronization and, of course, redundancy. This was always a topic in important assets. So we always had duplicated systems even before we even talked about IEC 61850. I assume that this will be also properly covered in this context?
Sure, absolutely. So it probably also refers to the hardware requirements. So what we have here is that, for example, our servers, they do have hardware support for PTP and also for redundancy protocols like HSR and PRP, which is also crucial. But if we're looking on the virtualization itself, well, usually you have 2 or 3 redundant systems in the substation. It means if even one server with your application fails, the hypervisor would easily handle it to start your system from the last snapshot you did on your system, 1 minute or even 1 second before it failed. So it would extremely shorten the failout, and so as soon as you install the new hardware, you would start from the last point, and you still have redundant system which would smoothly take it over and run the processes further.
So you could almost migrate in the operation of the system.
Yes, yes, absolutely.
As you briefly mentioned CPAC before, this is an open source solution, and we see open source software coming more and more. What role does it play in the context of vPAC?
Okay. Yeah, the question is clear. I believe before we go to the open source, we need to clarify why this topic is so important, why there are so many discussions on open source. Well, there's such thing as vendor lock-in, and I probably need to explain a little bit more what it is. Well, vendor lock-in is the situation when you're binding your operations to some specific solutions or products. So, for example, you have some devices which only use some specific protocol, and you cannot use it with other devices or within other applications. You cannot upgrade it in the future if you see some other interesting or more advanced solution on the market. But this is how the product business have been working for decades. I'm sure that you also had some experiences with that, right?
Yeah, what comes to my mind in this context is that IEC 61850 chose to go for Ethernet, which is a mainstream technology, although it has not been developed for this specific purpose. In the substation, it is more than good enough, and they made this decision back before the year 2000, where we mainly had 10 megabit networks, then we evolved to 100 megabit networks and gigabit networks, what we have now in substations, while the IT industry is at least a factor of 10 ahead of that, and we get all these developments from this mainstream technology without pushing them by ourselves. So they fall into our hands and make our systems always more performant and better. And even there in this area, there are tendencies to promise the customers more feature when going for some kind of specialized networking technology. But you must be very careful to go for that when you disconnect yourself from the mainstream.
Yes, it's true. And in regards of virtualization itself, well, there was a situation. I believe the first time I heard on this specific topic was on some of these Mudgrid forum events like 1.5 years ago, when we talked about vendor lock-in in virtualization. And then it actually happened when the utilities and also other players realized that the vendor lock-in could come true. I mean, the acquisition of VMware by Broadcom. This is where utilities thought, okay, that might be it. So that might be the vendor lock-in we were talking about, but we're not taking it seriously, because there were some certain concerns about further developments of the product of VMware, about the company strategy and so on. This is why I believe it's so crucial that the Broadcom as a situation communicates it to the players on the market and makes sure that everything will be fine. I believe it will be. But if we're talking about this particular situation, this is where open source solutions could be the way some utilities should go if they have so many concerns on vendor lock-in. Because what open source allowed, in simple words, that these products have been developed by a community, not by some specific vendor, but by the whole community of utilities and some players who did that. And basically anyone could develop this system further. So if you're taking a CPAC, everyone could just take this open source solution and develop it for their own needs, and also find some independent support vendor to support it, or even build the know-how within the company.
We talked a lot now about the technical aspects of such systems, but there is more to that. When I remember the Q&A sessions in conferences after a vPAC presentation, we often hear the questions about costs. But I need to say these questions are very often directed toward the equipment cost, to the CapEx, so to say. And I think the other aspect of the operating costs is a little bit underrepresented. How does this look like?
Okay, so in general, we don't have so much numbers from the substation automation because it's pretty new. But virtualization itself is not a new technology, as I mentioned before. So we have a lot of experience and information from the IT world in data centers, for example. And we can adjust it for our field because we already have some experience of several years in substations, and we can compare it. But what we need to mention is that, as you said, we shouldn't just look on the CapEx, but we should consider the life cycle costs of the whole setup. So, and then if we talk on the OPEX, the OPEX is reduced to up to 30% if we're going virtualized. And how we do that, we reduce downtime by up to 50%. We have much more flexibility, so we increase flexibility because for example, you use one platform for different kind of applications. It's only one platform, so you don't need to train your personnel for several different devices from different vendors. You only have one box you should be able to work with. So when, for example, something fails, it is much easier to maintain those systems. So you just need to have one additional box, and the hypervisor would start the system from the previous snapshot you've made. So it goes very, very smoothly, and you can scale those systems much better. As we talked about performance, we said that, okay, we should leave some performance for later developments, and so we have the scalability if you want to add some additional applications on your system. You can also easily upgrade your solutions. You don't need to install new devices, or you don't need to come over to this substation to install some upgrade. You can easily do this from your control room. When you have overview of all virtual machines, you can upgrade them, you can restart them, you can do whatever you want with that. And of course, you also have such additional point as sustainability, because you have only one server, and or two servers if you make a redundant system. But in general, if we talk, for example, about fanless servers, they have a very low power consumptions. For example, 50 watts. And this is the power consumption for the whole setup for all applications. And now compare it to several IEDs that would run in substations in a conventional setup. And in general, we can also compare it with the renewables. For example, if we consider installing some huge photovoltaic farms or wind farms, I remember these discussions in the very beginning, considering the CapEx costs and the generation costs of the electricity in the very beginning. While you have lots of CapEx, the generation or the cost of generation of the first megawatts would be extremely high. But if you take a long-term perspective of 10 or 20 years, the average cost of it is much, much less than in just usual power generation. It's a little bit similar to what we see here. So even if CapEx is higher, but I doubt it as well, so it depends on the architecture, the OPEX is much, much less compared to conventional substations, which makes the lifecycle costs of those applications much, much less than in conventional setups.
Yeah, and I also think beside the costs, there are simply possibilities there that we didn't have before. When I envision what we would now get in a substation, that we can back up a system, that we can restore a system by just putting the same image back on a new server when we want, for instance, to clone a system for some reason. We could go back to a well-working configuration. Just if a configuration change caused a problem, we could do that very quickly. We could even use a copy of the system to analyze some kind of behavior or do failure analysis offline in a copy without affecting the running system. And I think we haven't even envisioned everything that we can get from this.
Yes, for sure, for sure. Even 5 years ago, or even 10 years ago, if we talk about the differences between those setups and the today's setups, so you have much more options. You have the monitoring, which is way more better. You can, for example, you talked about the restore of the system, but in some cases you don't even need to go to the system and substation. When you sit in your control room, you can just reboot your system sitting on your working space. And of course, you have these benefits that you mentioned. We also have additional redundancy. We can analyze the critical situations when in terms of protection and control. And as you mentioned, we can really clone the systems and work with them in some offline environment. And we can also test those, right?
Yes, we could use such an offline environment, for instance, to apply firmware upgrades to the components in the virtualized system and test the whole system out if it still works properly before we deploy it on site. And in general, we get questions now about how such systems are to be tested. And I think the good news are it's not much different from that what we did before. If we start again at 61850 and how such a system is seen from that point of view, there was never a definition where a logical node which represents a function in 61850 has to reside hardware-wise. We just had this functional assignment, and then we found some box where this logical node then would reside. And in classical systems, it were those IEDs which were spread around. And we have these logical nodes or data models or servers now in one central device does not make much of a difference from our point of view when we see it from the testing side. So we would just connect our testing equipment still to the communication networks in the substation and then apply the test signals in forms of protocols and get back the responses from the centralized system instead of all of these individual boxes.
Okay, and if I understand it correctly, it means that virtualization would be also possible with the testing solutions, right?
Yeah, even there we see a pull from the customers that they say, now we have virtualized the applications. Couldn't you also virtualize the testing tools? This is a little bit a special case because it's not always right to have the testing tool depending on the same infrastructure as the devices under test themselves. So we always have advantages when we use dedicated test devices. And if a customer wants to have this in a virtualized form, we have to make some compromises and make these disclaimers. But these restrictions that come with that are well understood by the customers, and they consciously take these restrictions into account and still ask, can we get this testing tool also in a virtualized form to run it on the server that we anyway have in the substation. And this led to the situation that we have now already 3 products that we really offer as virtualized applications.
Yeah, great. Because I think it's a pretty new information for many of the listeners. And this is actually a great thing about virtualization, because you can actually run multiple applications on one box, as I mentioned several times. So it means that you can start applications that you would probably bring on your laptops or some other devices into substations. You can run HMI, you can run an engineering workstation, you can run a firewall that was previously used on another hardware box, or some other cybersecurity applications like your IDS system from OMICRON.
Yeah, interesting. Now we are coming to the topic of cybersecurity. It is not the focus of our talk, but we cannot avoid it. And you mentioned these engineering applications which would be installed on this server maybe, and not the technician bringing his notebook, which is nothing else than an attack vector from this point of view, and bringing in this danger to the system. So we can avoid also that. And in general, I think there is something in it also from the view of cybersecurity.
Mm-hmm. Right. Well, let's try to stay fair. So in terms of cybersecurity, if you digitalize more, you have more cybersecurity risks. So if you add additional digital devices to a substation, you are extending the attack surface. So there are more devices or interfaces that could be under attack. And you also make your whole system more complex. And you also have this human factor in the system. So you need to design and build your digital or digitalized system very carefully in terms of cybersecurity. But if we're talking about cybersecurity, there are also additional opportunities that you can utilize when we talk about virtualization, because first of all, you have much better monitoring and analysis possibilities, because you have a very clear overview about your traffic in the substation. In terms of, if we're taking the firewall or the IDS system, it has access to all of the ports, whether it's a physical or a virtual ports. You see all the data moving between virtual machines, and you have a great overview also from your working space wherever you are. And you have also much faster incident response, because you can immediately react and see all of the notifications wherever you're located. And you have also automated security updates. So you don't need to physically go there. You can install all of these updates remotely, and also within this one hardware product that you have in your substation. So in general, there are some challenges, but there are much more opportunities. And I believe that once we decided we want to digitalize, we should just accept the fact that there are cybersecurity risks. But that doesn't mean that we don't digitize at all. It means that we need to take some measures to minimize those risks.
Now, making the balance between the challenges and opportunities in terms of cybersecurity, I think the opportunities will compensate the challenges, and there is nothing to fear. And I'm very interested to see the experiences that we will make when cybersecurity applications will also run virtualized on such platforms in a substation.
Yeah, thanks for your perspective. So we raised many aspects today, and I think it's time to summarize the conversation and try to look in the future. Well, I personally believe that in the long term, the ongoing digitalization will not only increase efficiency and stability of the grid, but would also contribute to a more effective and sustainable energy supply. And I believe that the industry is now on the threshold of an era where digital technologies, and virtualization in particular, are considered not as dangerous and threatening, but as a backbone of efficient and effective power supply. But we all need to contribute to make this happen. And I believe that the collaboration between vendors, manufacturers, application providers here is crucial. But this is a very long way, and you know it much better than me. And we all need to contribute to make this happen.
Yeah, I think the future has already begun. We see the changes happening in the power networks, and we are not asked how much time we would like to have to solve the challenges that come from that. So there is a pressure already coming up to bring solutions to these problems, and we have to speed up. And anything that makes us more flexible is very welcome in this regard, and the potentials that are delivered by CPAC and especially vPAC solutions are something that will support us very much in the future.
Thank you. Thank you so much, Fred, for this conversation. And we are coming to the Q&A session now. We'll see you in a couple of moments, and make sure that you prepared your questions, and please use the chat to write your questions, and we'll refer to them. Since our conversation was not that long, we were not able to discuss all of the questions in detail, so we hope that through your involvement, we'll be able to raise some additional points. See you in a minute.